In the last period, he's focused on developing low-cost digital solutions for small and medium companies. Also some solutions for the Boeing company. It's also small and medium. After all these changes there, it will become medium-sized company. And as a matter of fact, he is also in some sense connected with CIIRC. First of all, he was building one of the first test beds around the globe using ideas which we call today Industry 4.0 because it was flexible manufacturing test bed consisting of 4 robots or more. More now, but yeah, 4 at the beginning. We met already, it's maybe 20 years ago when you started in the old building of your institute. You started with the test bed with agents which communicated and you used RFID tagging to understand when the product is located and so on. So pioneering work, and in our application for CIIRC, we mentioned this test bed at Institute for Manufacturing at the University of Cambridge as a, let's say, template or pattern how it should look like in a country which would like to develop industrial automation systems. So that's first connection of Duncan with this institute, and he's serving now on the international advisory board of both CIIRC and RECAI project. So he's providing advice also to us how to improve our institute, how to improve our RECAI solutions. So he's spending now, and I'm very glad that he was able to come after 20 plus years. Maybe 20 years. He arrived to Prague and is spending 2 days with us, consulting many of you and giving a talk. So I think as introduction, it's enough. I'm giving the floor to Duncan, to Professor Duncan McFarlane, and we are looking forward to his presentation. Duncan.
Okay, thank you. Thank you. So I need to use this, do I? Okay, right. Because I have a very loud voice anyway, but anyway, I would do this. In case I break it, I want to sing some songs later on anyway. So thank you very much, Vlad, and I should say I've really enjoyed my visit, and thank you to everyone that I spent time with yesterday. It was really great to see the facility that's developed. Fantastic, and as Vlad said, we had some connections for a long time now, so it's really good to be here after quite a big gap. So today I'm going to be talking about something a little bit different to what we've been discussing in the last 2 days, and it's some work that I've been involved in since 2017, and particularly, as it says here, looking at the issues and challenges that very small companies face in trying to become a bit more digital than they are already. And so the first thing to say is there have been a lot of people involved in this work, and I should say it's called Digital Manufacturing on a Shoestring is the kind of the catch title, but maybe 30 or 40 people over the last 7 or 8 years have been involved one way or another. So I acknowledge their inputs. This is really just a summary of that. So what I'm going to do is talk a little bit about the background to the small companies and some of the ideas behind what we mean by low-cost digital solutions. And then I'm going to focus on 3 key things we've had to work on. One is helping organizations to specify solutions. The second is how to design low-cost solutions systematically, and then how to deploy them cheaply. And then I'll wrap up. So in theory, this is about a 45-minute talk. Sometimes I go a little bit longer, and I'm sorry. So firstly, I just want to make one very small point. If you look at research topics at the sort of conferences that we're involved in, IMS, IFAC events, IEEE events, it's very rare that you see the word cost as a research issue. Most research is around building new functionalities, new capabilities. And, you know, I've done a lot of work on flexibility and reconfigurability, and I know you all have here. So for me, this is kind of a change, but, you know, there's some history of low-cost driving research ranging from, you know, the beginning of mass production of automobiles to the biro, the ballpoint pen, which was really a mechanism for making ink pens available to many more people. And I was involved, as Vlad mentioned, 20 years ago in something called the Auto ID Centre. And the Auto ID Centre was looking at radio frequency tagging, and radio frequency tagging before 2000 was only in library books or ski passes or road tolling systems. So our project was to try to reduce the cost of RFID tags by 100, by a factor of 100. And we nearly made it. So today you can buy an RFID tag maybe for 5 cents US, perhaps even less now. But interestingly, where people do use cost as a driver for innovation, you know, well, firstly, it's often because the status quo is a bit stagnant. So things have got comfortable, or and people seem happy to buy. A market seems happy to pay for quite high prices, but there's possibly an untapped market available as well. It can lead to process innovation, not just new products, but innovation in the way process is developed, and often, you know, it has to be scaled up very quickly or needs to be cost effective. And this is really important, leads to other knock-on developments. So all those examples there did that in one way or another. So I'm not talking about any of those today. I'm talking about this, low-cost industrial solutions. And actually, this project or this whole activity began with a student that came along to see me in 2017. He said, oh, I have a 6-week project. I want to solve the world's food waste problems. I said, oh, so often in Cambridge, our students have quite big ambitions. I said, maybe you can't do that in 6 weeks. He said, oh, also, I want to come up with a smart fridge. And so I kind of laughed. But anyway, we were working with Tesco at the time, which is a big supermarket chain in the UK. And the student said, I want to have a go. And in 6 weeks, he nearly built a smart fridge. And he did it by, he took the GoPro camera off his bike helmet. He got a Raspberry Pi microcomputer from a friend. He took some software from an MIT website and got some wiring and some sensors from our lab. And his aim was to try to monitor the level of milk in the milk bottle and some other contents as well. So he did it in 6 weeks. I thought this project should be a 2-year project. That was the way we did it then. So I was quite shocked. He didn't finish it exactly, but in the next month he came back and finished it. So that was interesting. The other thing was, you know, and we talk often about this, is that in our industrial automation field, there have been really quite slow developments. So the PLC is the dominant element, and PLCs have made many changes, but they're still quite similar to what they were 30 years ago. And also, actually, many PLCs are still in use from 30 years ago in many companies. So it's quite a slow-moving area in industrial automation. Similarly, and Vlad mentioned I work with Boeing, but in work with other companies like Unilever and Amazon and Michelin, I came across people doing new solutions in a one-off basis using non-traditional digital technologies. So using a Raspberry Pi or an Arduino or a Wi-Fi camera to develop simple digital solutions around their operations because they couldn't get them to work directly with some of the industrial automation infrastructure. And this is very good, but for example, when I talked to Boeing, Boeing said, oh, we don't know what to do because we have all these crazy people in our company doing solutions and they don't document it, they don't explain it, and then they leave and we can't use it anymore. And in fact, the guy in Michelin said, you know, I think I'll get sacked soon because I'm encouraging all this rogue behaviour in the company. So there were, you know, this was back in the mid-2010s, and you know, in the mid-2010s was also when Industry 4 was evolving. So what we started to think about there was, could we take these sort of ideas but take a more systematic approach to build low-cost solutions for industry in some ways. So that was the first thing we looked at. The second thing that happened was Industry 4. And Industry 4 happened at that time. And I went to a lot of industrial workshops in the UK and in Australasia. And I had a very interesting workshop one time in Melbourne where I was sitting looking at a really impressive proposal from Siemens for a top-to-bottom IT infrastructure. And the guy standing next to me, I said, you know, is this interesting? You know, are you a manufacturer? He said, I am. Is this interesting for you? He said, it could be, but I can tell you I'll never have it because it's too expensive and it's a big solution and my company has small problems. And so I thought, and it turned out he was, you know, his company had 30 or 40 people. They wanted to do digital deployments, but some of the offerings that were coming through just didn't seem to match what they needed. And, you know, just some interesting statistics here. Depending on where you are, in Europe it's 250 is the limit of SMEs. In North America it's 500. But here's the really interesting fact. Most manufacturers in the world, 99% are SMEs. It doesn't matter how you measure it. And you know, there's about 368 million SMEs in the world. The estimate is maybe 30 to 40 million of those are manufacturing SMEs. So that's a lot of companies. And that's a lot of companies that are a bit like the guy I was talking to, who can't really understand how to use digital systems in their operations. And I'll expand on that a bit. But, and so, you know, these are just some numbers I was collecting over in recent times. We tried to do an estimate this morning. Maybe there's 30,000 manufacturing SMEs in Czech Republic. So this is a big generalization, but many small companies either begin because they have one product they want to make, or they actually have a machine and they want to make some products with that machine. And many of the small companies I visit do something like that. And in these small companies, because there are not many employees, every person has to do everything. So everyone is no one's an expert, but everyone is doing everything. They haven't got much money. They've got very limited IT and automation expertise. And I mean, that means they can't specify, let alone build a solution. And sometimes they're at odds with Industry 4. And by that I mean, Industry 4 is around how we use some of these emerging technologies in AI or machine learning or augmented reality, etc. Many small companies are not at Industry 3 level. In fact, often they say Industry 2.5 is standard for small companies. So to make them digital is possibly too much to expect from Industry 4 to begin with. So when we started to think about what we could do with small companies, the message we got very clearly was we're interested as long as you build simple, low-cost solutions for which the whole cost for us is very low. And that just didn't mean the equipment, but the development and the deployment. So everything had to be kept low. So that was our challenge point. In the first part of our project back in 2018 it began, we started talking in more detail to small companies, and maybe within the first year we talked in one way or another to about 300 or 400 small companies. And not only did they have not much money, they had actually, when you said, do you want to be digital? They said, yes, but we have to do it for the problems we've got, not for what you're trying to give us. They didn't know even what solutions were available for their problems. They didn't have the capabilities to understand the solutions. They didn't have dedicated time, and they were really worried in the future about key staff leaving. That was a big challenge. So we had to put together an approach that not only technically developed solutions, but actually did a lot more. And so I'm going to talk actually about the whole problem, not just the technical part in the next sections. But before I do, I just want to, so I'm going to talk in those three sections: requirements, design, and deployment. So not only we've got to design, we've got to, how do we effectively deploy the solutions? And as I said, before I go into that detail, I just want to mention this shoestring project. I'm sorry, I'm blocking your view as well. No, I'm not. Okay. Is this the best place to stand? Maybe in the middle. That way I've got the column here. Okay, perfect. So we came up with this idea called shoestring. And anyone that's as old as me, and not many of you are, maybe Vlad is as old as me, there used to be something called a shoestring travel guide to travel in Europe. And it told you how to be very cheap, but have a good time traveling around Europe. And so we used that as our title. And it was the shoestring. Shoestring is a process. It's not a solution. It's a process that generates solutions for integrating low-cost technologies to address the needs of small companies. And we began it with a research project, and that ran for 3 years, 3.5 years. And it ran all the way through COVID, by the way, which is important. And during that project, we had 50 partners. And during that project, our partners said, well, what happens when this project ends? Because we thought we would have 2 test beds. We ended up with 20 in companies, 20 trials in companies. So we had to build a new, we needed a system to take these outputs, which was these low-cost solutions, a simple architecture, but also ways of helping companies understand their needs and training the companies. And we built that into a business activity. So we have within the Institute for Manufacturing in Cambridge a business unit that manages not only our research programs, but also we run regional programs in different parts of the world, advises small companies, and also works with apprentice and training organisations. So that's what the shoestring program has done. I'll come back to where we've got to at the very end, but I'm now going to just go into the processes we've used. So firstly, as I said, actually, the companies we talked to said, well, look, we kind of know what our needs or our issues are. We don't know how digital solutions address them. And so if I go back to that chart I put up before, the items in red were really the key things we had to achieve in the needs and specification area before we could even begin to design a solution, because actually we began not knowing what small companies needed. We thought we did, but we were kind of wrong and right. So this is my whiteboard back in 2018. So we spent a little bit of time talking to some companies we knew quite well, and we came up with 20 ideas for digital solutions that might be useful for small companies. They're quite hard to read, but they're simple things like vibration monitoring or real-time tracking or digitizing their job cards. So they're not big automation solutions generally. And in the end, we came up with what we called a catalogue, which identified the top 40 to 50 solutions that all small companies asked for over and over again. And we did this through a series of workshops which we ran across the first year of our program. And that catalogue included some solutions that we didn't believe were suitable for low cost. And so you see on the right-hand side there, all the many things, if you want something that will run 24 hours a day on a safety critical process and needs to be fully automated, then don't try to do it with a low-cost solution. I think we all know that. So on the other hand, what we found is many of the solutions in that catalogue I just mentioned were actually compatible with using some low-cost technologies, mainly because it didn't matter if it failed from time to time, it didn't matter. It allowed a company to get started on trying some digital ideas. So, for example, some of the things, for example, I'll just show you a quick video of one of the companies that got involved. And what's interesting in what he says is many companies had one machine that was really well automated, but all around that machine, there was manual processes. So a lot of the shoestring work began focusing on the manual processes around the main production operations.
Yeah, so within our business, it's really important to look at manufacturing digitalisation because there's only so far you can go in reducing machining times and process times, and it's a lot of these periphery events before and after where we can show some greater gains and maintain a leading edge on cost effectiveness within businesses. Within the digitalisation process, we've already introduced quite a few technologies, and one of the leading things we would like at the moment is with 400 or 500 jobs going through a factory in the week across multiple processes, knowing exactly where each job is at any one time. Particularly if it's moving from one operation to the other. So if it's just finished one and about to start the other, is it still where it finished, or is it about where it's just about to start? And a heat map showing where these parts are would be invaluable in saving a lot of time. Introducing digital technologies in small SMEs generally can be quite cost prohibitive, and a lot of the things that we're talking about within the shoestring projects generally are very low cost, and it can give you a snippet or a flavour of what the art of the possible is. A lot of...
I'm going to leave. So yeah, so I mean, you get that message. You know, he was one of the initial partners in the program, and what they were after was to try a whole lot of things in their manufacturing environment around their production systems that they hadn't had a chance to try before because the solutions were too expensive. So the sort of things that came up in our early discussions were solutions like this. Some of them are more predictable than others. So by far the most dominant suggestion for people was the bottom left. So and job tracking. So actually, I'm making a job for a customer, I don't know where it is in my factory. Really, so if you're a big company, you have a good tracking system. Small companies tend to just go and look for things. And we found many companies were wasting vast amounts of their time looking for items. So this was a number one solution. Monitoring of equipment for initially vibration and temperature, but actually increasingly energy monitoring has become a really important issue. Monitoring of the processes, and I'll talk more about that later. But this one is very interesting. We had many companies that were saying, you know, we have data systems around our factory that we have to go and manually check all the time, like a light stack. And we know we have these lights that say red when the machine is not operating, green when the machine is operating. We don't have any digital record of that. It's just so the solution there was to point a camera and just look at the colour of the lights. Or here, companies with old panels with a display, which they couldn't get a digital signal for. Again, we did some image processing, some simple machine learning, and built a solution that created a digital signal, a digital equivalent of that analog display panel. So those you can see they're all peripheral solutions. They're not core automation solutions. The second thing, one of the other things companies talked about was, you know, we have to build business cases. Our boss says you need to talk about a business case for making any investment, and we knew that is often a prohibitive issue for a small company. So we actually developed an approach, a really simple approach, which basically identified basic benefit areas possible and in a short workshop of about 15 to 20 minutes with the company, identified where they were going to get benefits. And they would use that instead of a business case in their process. And we then went back later on and did some auditing of that process. And what we generally found is any benefit they identified, they got a benefit, but there were also many others that they observed and didn't actually anticipate. So, and this is very typical for most digital solutions actually. There are many more benefits than those that are actually quantified at the beginning. And in fact, we've done quite a lot of work on something called value of information, which is some of our more academic work connected to this, and we've come up with methodologies which you can broadly use for coming up with a value in terms of impact on the business of digital solutions. And then finally, one of the key things we found is that many companies, of small companies, have people that understand their processes really well, that understand digital systems very poorly. And yet what we needed is to help them build a solution that is going to work. So we developed a methodology, a simple methodology for just capturing their verbal requirements in a specification structure. And this structured specification is designed so that it can be relatively simply turned into a technical spec. So that kind of gives you a sense of the way we had to build a structured support for a small company. And note, I haven't talked about any solution development yet. So this was everything that needed to be done to help a small company get to the point of identifying what solution they needed. So quite heavy work, actually. But what I would say is we've now reduced this down to a 1 to 2 hour session with the company. And in fact, we're moving to a point where companies will be able to do it themselves, or perhaps do it with a local facilitator. So shortlisting the solutions they're interested in, prioritising the ones that will have the best benefit, identifying the features for their solution, and then building this formalised specification. So that leads to the next part, which is, once we know the solution, how do we design a systematic low-cost digital solution for a company? And again, I should say cost has been a challenge all the way through this, a dominant challenge. So here, if I go back to the original set of company challenges, this is about how do we use low-cost technologies, how do we make solutions simple and transparent, because people said, I want to understand what you're doing, and there's a reason for that as well when we get to deployments. It's here actually. We wanted to involve the end users in the deployment, and it needed to be systematic, extendable, and repeatable. So I'll talk about that next. So way back early on in the process, having come from many years of working with modular reconfigurable systems, I proposed a solution architecture for these low-cost solutions. And the logic behind it was something like this. We have all off-the-shelf low-cost technologies, and although we can identify them at any given time, they're always changing. So for example, Raspberry Pi, who we work very closely with, they bring out a new model every week. And I think they're aiming to do more. So, how do we keep pace with this? So our approach, and it's a very obvious approach, was we said, okay, we will think about microcomputing platforms or image capture platforms or voice recognition platforms, cloud storage, etc. But think about them as having standard interfaces. It didn't matter what the technology was, it would be a standard building block in our design environment. And the idea was these standard building blocks could be combined to form reusable elements. We call those reusable elements service modules. And this just, for example, a data collection module, a data analysis module, and we build our solutions from service modules. And the service modules, the idea with this is we needed to be able to reuse designs over and over again, because otherwise we can't keep the cost down. So that was the starting architecture. And in fact, we more or less have kept with that architecture since the beginning. And one of the reasons for keeping with it is that we also did a survey of different architectures available for building individual digital solutions. And we're all familiar with many, many papers on reference architectures for manufacturing systems. And we reviewed, I think, 80 of them and found that there were only 3 to 4 that actually addressed the building of one solution as opposed to the enterprise operations. And so I won't go into great details, but we did a quite extensive study with 3 candidates. So an early Holonic one, conceptual architecture using the Erlang programming language, a Web of Things is an emerging approach to web-based object integration. And we weren't aiming to prove that shoestring architecture was a great architecture, but simply that against some other candidates, it performed fine. And these candidates, it wasn't a particularly fair comparison. These weren't particularly designed to deal with the low-cost challenges the shoestring deals with. But anyway, in that analysis, shoestring came out with good results in doing many extensions and reuse and integration tasks. So we feel kind of comfortable that we've got an architecture that is sensible. We then put together a design approach. And our idea with this design approach, as you'll see at the end, was that in the future we don't want to be building the designs. Someone else will do them, or they'll be done automatically. And so this is familiar, I think many people familiar with digital systems design will understand the V-curve. So specifications down the left-hand side, and then building and construction up the right-hand side. And in the middle for us, key issue that is not often always an issue is we always need to identify the right base technologies at the time, the lowest cost options. So to make this systematic, we've built a series of catalogues that I talked about earlier and templates for doing designs so that other people can be doing these designs as easily as we do. And one of the things we're working on right now, and generative AI has made a lot easier, is low-cost technology classification method. So the way it works, and I'll go through it quite quickly, is that we start with that user specification, and we have a methodology for turning that into a more standardized solution specification method. So we capture typical things like information sources, outputs, which data we need to make use of, which physical operations do we need to interface to, and sometimes not at all. And then we decompose that into the service modules I talked about before. And actually what we found is that if you think about everything we do in a digital system, it normally comes down to one of 7 types of operations. So gathering, sensing, analysing, recording and storing, deciding, reporting and actuation. And so whereas we began thinking we might need to develop many of these service modules, in fact, we found that with 7 basic templates, we can build any solution. I don't think that's not revolutionary. That's quite obvious when you look at the names. And we do have variations within those different service modules, but every solution we built so far has been built with just these 7 elements. So within those service modules, then obviously have to get decomposed into building blocks. And the building blocks would either be hardware building blocks or software building blocks, and in fact, sometimes hybrid building blocks where we have a mixture of hardware and software. But I was talking to people about standardizing interfaces yesterday in some of our discussions. And this is what we're trying to do here, is to come up with a limited set of power, signal, comms interfaces in hardware, and then communication protocols, message structures, data formats, etc., and ontological organisation for data, in order that if we have our building blocks complying with these specifications, these interface standards, we can always connect them together. So we're making some progress there. It's still, we're certainly still not there with the building blocks. This is the hardest bit. Our service modules are quite mature, but these still need some more work. And then, as I mentioned, one of the current things we're looking at a lot more now, we began 5 years ago, and it was almost impossible. We were trying to understand how to explore available information sources to classify types of building blocks, or types of technologies that supported our building blocks. I'm sorry, this is not easy to read. So, we've got our actuation elements there, our sensing elements here, our user interface elements, etc. Actually, they're listed. They're all listed along the side here. So these are our classifications of the building block types and the type of technologies that we might want to use inside them. This is not a comprehensive list, but this captures some of the early stuff we were starting to build. And you can zoom in and just see the data collection elements there. So vision systems, sensing systems, etc. Much bigger lists available now. So once with the base technologies, we then build our building blocks and integrate those building blocks within these service modules, and then finally aggregate the service modules to form a solution. So this is an instance. In fact, if I have time, I'll show you a short video of this system. Perhaps I won't have time, actually. But one of the early developments we did was with a company that made dental wax, and they had no automated system for gathering temperature measurement, which meant that they had to walk around and check temperatures of their dental wax all the time, which was critical if you were going to make a mould of someone's teeth. Anyway, that solution was developed during COVID, so we never went there. We did it all over the phone, and they actually did the deployment themselves. So where we've got to is we've developed this architecture, and we've developed 20 different solution types, lots of variants within those, using the same architecture, the same service modules, and the same interfaces, but in many cases, different base technologies. On our website, we're actually selling simple solutions for some of the most commonly requested problems, like job tracking I mentioned before, temperature monitoring, monitoring scrap levels, downtime monitoring on equipment, power monitoring. So these have all been built with the same solution architecture. And where the design work is going now, as you might have guessed, is how do we do this in an entirely automated manner, or at least in a manner that someone with no expertise can build their own solution, but just simply by moving jigsaw pieces around. And this is an extract from some work we did using a package called Blockly for automating and actually automating the code generation for the building blocks. So that's in a really quick way, that's the description of the design process. The final element, though, is that we built the designs, and actually we realised if you want to keep it very low cost, you can't afford to spend much time with a company doing a deployment. Perhaps you can afford 1 hour of expert time in helping the company do a deployment. So if you think about how many solutions you develop that need more than 1 hour, you can see that's quite a big challenge. So we've done a lot of things to try to reduce the amount of effort and improve the amount of local support that might be available for developing. So this is about some of these issues here. To keep the price down, we need to spread the cost of designs across many deployments. We want to keep the support low, minimise expertise use, and this was really interesting, get the end users involved in building their own solutions, which turns out to address another major issue small companies have in skill development, and make the solution systematic and extendable. So I mentioned that catalogue earlier on. One of the other things we did in our early workshops was got people to assess which of these catalogue solutions were most important for them. And what you see here is a Pareto of the top 15 solution areas that companies identified very early on. And so I mentioned the job tracking was number one. Certainly it wasn't until the end of 22. It has changed now. But these are the solutions, and actually what it turned out was that 86% of companies we talked to actually needed or wanted one of those top 5 solutions. And actually 98% of the companies wanted one of the top 15. So what that said to us was, actually, we may not be able to solve every small company's needs, but actually if you could build the top 15 and find an easy way to deploy them, you could be solving many small companies' needs. So it's kind of, that's the difference. No, we had to get away from the idea of we're not there to solve every small company's personal problems, but find the problems that most small companies have. And as I said, yeah, we've involved now probably more than 500 companies have been involved in understanding these sort of priorities. So one of the things we did is realise that we had to come up with nice ways in which, without having to be on the phone or in the factory, we could help companies deploy solutions themselves. So we had to develop a systematic deployment process. We built a community forum. We built guidelines for self-start programs for the companies to get themselves going, and they could actually get a mentor and work in a group to do that collectively. And as I mentioned before, we also built these really simple starter solutions that you could get a kit sent to you in the mail and follow 10 steps and have the solution running. So, you know, it's not, clearly we're not automating a big production process, but this, you know, for scrap monitoring, you could set up your own solution and have it running quite quickly. So I'm going to jump across this. This is the example of the temperature monitoring system. And the one thing I will just say here was that, you know, with that temperature monitoring system, the production supervisor in the factory deployed it. And we simply provided support over the phone, and the production manager was the guy that rang us to start with and said, could we help him? So actually, we were still inefficient. We probably made 10 to 20 phone calls with the company, but a lot of the time now we can do the solution deployment in 2 phone calls. We'd like to get even lower. And it had significant benefits for the company in the area they wanted, which is in quality control. But also, it actually, they started to use the temperature system they got with a simple dashboard to diagnose other problems they had in the factory, which they hadn't anticipated being able to do. So I'm going to jump that. So the other thing we did, and we started to do actually in 2021, was to realise that there are many regional manufacturing associations that are there that are set up to support small companies. And because actually it was very hard to get small companies together, we used the manufacturing associations to do it for us. And actually, the one in Scotland we were working with said, you know what, we think we could set up a shoestring program in Scotland. So we ran a pilot with them, and we spent a lot of that pilot actually trying to build the right team in the region in order to be able to deploy solutions. So we spent time training them, the regional associations, finding solution providers. We got universities in Scotland and technical colleges in Scotland involved as well. And another example of a development was during the back end of COVID, we had a phone call from Western Australia, and they'd heard about the shoestring program and looked around the world to find a way in which they could deal with the fact they have very, very small food and drink companies, so wine makers, beer makers, agricultural product packages, and these small companies had no digital capabilities at all. So we set up a program with the Western Australian government, and I've just come back recently from being there, where we ran some workshops with the wine producing section called Margaret River, south of Perth in Western Australia, and 20 companies there are in the process of doing a shoestring pilot. So I'm going to show you a short video of some of the work that's come out of Australia in that area, I hope. maybe this.
Well, for us, Shoestring was a bit of a revelation in that it brought a number of people in the organisation that had nothing to do with using digital technology into a place where now people are starting to think about other applications as to how we could improve our process. It's been an opportunity for us to think more laterally. So now, instead of trying to think about a solution in-house with either a butchering operation or a movement of people around the place, we're now thinking outside the box as to how we can actually implement something that's technology-based that could give us the same outcomes.
Since implementing our power monitoring solution, we've been able to identify the uptime and downtime of our equipment, and we're starting to get some good results to identify a baseline power usage of those items of equipment. So we'll shift it around through the brew system until we've got some good baseline readings. Once we've got those baseline readings, we'll be able to use those to target items for upgrade from a sustainability point of view, identify items that are using too much power, and potentially change our process to better utilise that equipment. The efficiencies that this will bring to the business in the long term is that we will be able to reduce our power usage and save on power consumption that way, and also improve our efficiency and our production output by better utilising the equipment that we have.
So we pinpoint a couple of areas that we could use these shoestring solutions. One of them was a simple power monitoring control. We are working a lot on our carbon emissions, and for that was a good starting point. With this simple power monitor solution, we can attach literally this small clamp to different big machinery that we utilize here. And we wanted to monitor how much power we consume, especially through a busy time of vintage.
What we did.
So I mean, in that brief video, you know, the three people speaking, there's the factory director of the meat company, the finance manager in a brewery, and the winemaker in a wine company. So not technical experts, they were the people doing the deployment. And you know, what you can see is that they're doing it to try an idea out. And maybe in the future, they will swap the shoestring solution for a more permanent solution. But up to this point, they had no base case to understand to what extent some of that data might actually help them to improve their business. So they're nice examples of small companies. And I think the meat company has 40 people. The brewery has 8 or 10 people. And the winery has 12. They have other people in the vineyards, but in the actual winemaking, and they make a lot of wine, very few people. And that's very typical. So that gives you a sense of how the deployment process has to work, even if once you've got a design in place. So I'm just going to wrap up now. So back to Shoestring. Shoestring has we've worked with a lot of companies. This is just a summary on a page, but actually I think we've now just about passed 250 solution deployments in small companies. We've got this. We've done a lot of these requirements workshops, understanding what companies' needs are, and the original catalogue of 59 is now reduced to 39. And from that, we've built 12 of these sort of starter solutions that we're directly giving away in kits or selling in kits. We're operating in 7 countries, etc. And also, just mention this stuff down here, we're starting to work much more because this is the sort of thing that we can train apprentices and further education students to develop digital skills with. And so we're starting to work with a lot of FE colleges in the UK and elsewhere to train their students. We're in a number of different countries, so we started. So I haven't got a map. This is the first 20 companies we worked with. I don't have a map of the 250, but these are our regional programs we're running in different parts of the world. So we've just ran one in Egypt back earlier in this year, and hopefully we'll be running in 6 other North African countries in the new year. And just a final comment on benefits. I mean, these are the benefits. We did an audit for a number of the solutions we'd already deployed, and they're nice benefits. But I think this one's really interesting, is that every company we worked with, because of the fact that it's actually too expensive for an expert to deploy the solution, they've got to do it themselves, they learn quite a lot about digital skills, but it has to be very simple. So, just to come back to that SME issue, this is the challenge, and Vlad and I were talking about that this morning. SMEs are the industrial long tail. They're the part of industry that's really hard to work with, because 50% of the revenue is with about 1% of the companies or less, and the rest of the revenue is much more spread. So and we do hear about productivity in SMEs being a major challenge. We do hear about digitalisation being a potential solution path to that, but it is a hard process to find a way to get to these small companies. And this is the extreme case, less than one employee. So like the owner is the company. So then, finally, just a comment that we thought when we began we were just doing the red area, and in fact the reality of what we've done is as much effort in the front end and the back end of getting our designs specified and deploying them. And I think it's been very interesting, but a much more work than we thought, and hard, even though the solutions are very simple. So that really takes me to the last point. Is Vlad talked at the beginning about the sort of my history of what the work I've been doing, and I think this is kind of where I was. All my research historically has been around coming up with clever solutions which add functionality to existing solutions. They're challenging to deploy and required quite a lot of effort. Then we needed experts within the companies we worked with, and the benefit area was around total value, so benefit minus cost. Whereas this program has actually been in all the other areas. So most of the work has been on coming up with a good solution process, not the solutions. Cost has been the only driver, or the main driver. Keeping it simple, finding problems that are simple and rejecting problems that are challenging is really hard. It's really hard. Actually, we don't reject them, we just pass them to another, start a different project, but they're not to do with Shoestring. We know we're going to be working with beginners who've got limited money. So on that note, I'll stop. Thank you very much.
So now the questions, please. Who will start with questions? Please.
Yes. Yes.
How do you want to deal with that?
Okay.
Because then the software becomes much more complex than if I do it just for one customer.
So this is a great, perfect question actually, and which we haven't exactly solved. So when I talked about the requirement specification that we did, and actually, what we found, and if I maybe use job tracking as an example, is that in order to go from the basic solution to a customized solution, actually 90% of the changes people ask for are really simple parametric changes in the solution environment. And we're actually about to start testing a prototype customizer that actually will automatically allow an end user to choose, for example, the simplest one, how many scanning stations for tracking jobs? Is it 2 or 4 or 9? They could just enter that parameter and the code will auto-generate around that. So there are many simple questions that we can customize, and actually for a company, often that's almost all they need. For the more complex customization, we need to be getting the auto code generation side of things worked out. And as you say, the more you customize, the more complex the code gets. So sometimes we're actually saying still, we don't have your solution. And for me, it's really hard, you know, and we learnt the lesson in the very beginning. We worked with a company that wanted us to develop an image solution for looking at wire that is made from many threads and quality inspection. It seemed a nice, interesting problem. After 3 months, we realised it wasn't shoestring. So we said to them, we can't solve this problem. We can, but not in this project. So actually, for shoestring, it's a very different mentality. Because we look at the fact that in the UK, there's 260,000 small companies. If we can help 10%, we're very happy. And it may mean that we have to reject another 10% to do this. So some of the customization questions today are answered by saying no. In the future, maybe we can do better.
Okay, next question. Who's willing to cover the position, please?
How did you make the companies participate in shoestring? Because it's very common in the Czech Republic that companies, especially small, medium enterprises, don't want to get involved in such programs like this, whether it's too complicated for them or maybe lack of money, lack of time. So how did you make them cooperate?
And you know, as I said early on, in the beginning, we had this idea, we run a workshop in Cambridge. Disaster. And we had a number of disaster workshops where not many people came. So actually, the answer was, and we were very lucky, we had many industry associations join the program. And we got asked more to join. And those industry associations have regular meetings with local small companies. And we asked these industry associations, could we have 40 minutes in your meeting? And in the 40 minutes, we ran a prioritization workshop so that by the end of that 40 minutes, the small companies that came knew their top 3 priority digital solutions they needed. And actually, that was very effective. Then we had people rang us. And as I said, in that project, we only wanted 2 companies to allow us to test. And we had 20. And actually, once we realized we could do it over the phone. In fact, we had to do it over the phone because of lockdown. We actually did many more deployments that way. So we learned, COVID for this project was really helpful because we learned how to do things remotely and with not much support. It's still a problem. It's still a challenge. And why we do these regional programs is that in every region, say Egypt has a really nice infrastructure of government or there's European Bank of Reconstruction and Development funds consultants in Egypt that spend all their time in companies. And these consultants go to companies, but they often don't have a solution for the company problem. So now we've trained the consultants to go to companies and not always can they find a shoestring solution that works, but if they can, then it's quite quick to do it. So we work with regional experts and we just empower them. We don't try to be the people going to the companies all the time. So, but this is the hardest thing. This is the hardest thing. Once we got a company in the door for a workshop, easy. Because, you know, these solutions in UK, maybe, you know, the equipment, and to begin with, we only charge for equipment £400, so 400 or 500 euros for temperature monitoring. Or for job state tracking, the company that we first worked with on that, they had been told £50,000, so 60,000 euros for a solution. That is 2 years of their money, their capital budget. So when we said, well, we probably can use you as a test case and it will cost you £600, 700 euros, actually that was quite easy. So once they see it, they're okay. But getting people to come to a meeting is the hardest thing.
So actually I'm wondering how big part of the Shoestring team needs to be focused on customer support, because typically with deployment, the customer side, the process just start. And this is something that's typically a big pain for us to support our customers.
Yeah.
So how do you tackle this challenge?
So this is our current big issue, because actually, to begin with, we mainly did pilot deployments. And, but in the last year, we've gone from, in fact, our deployment curve is something like that.
Mm-hmm.
So in the last year, I think we've deployed 150 solutions. So there is a support issue, and we're actually designing a platform now to provide as much support as possible, but we actually need to build a kind of a micro subscription model for people that want support. So at the moment, we haven't got a good scalable support offering. I hope within 3 to 6 months we will. And even for hundreds, it's not that bad. Because, and actually, we have the two most common support requests are, one, it doesn't work at all, and we say, is the power on? Okay, that's... Second one is, because in one of our projects, we upload everything to a data lake. And the other one is the Wi-Fi's gone off. So they're the two main problems. But there are some more specific problems with a Raspberry Pi failure or a sensor failure. So far, we haven't had such a big... our systems are performing better than we expected, but we know that's our problem, and we've just employed a new head of the Shoestring unit, and his issue is how to build a subscription model for people to give them support. Yeah, so that is definitely... I mean, but our support is much simpler than the support you would need to provide. Yeah.
Thank you.
Another question? No more. So Duncan will stay with us after the presentation, so you can also contact him directly and talk to him. What we have learned today, that we are offering to our industry, to our small and medium companies, high-level solutions, a lot of mathematics and deep learning and, I don't know, fuzzy logic control and whatever. They don't understand what we are offering to them. That's why they are not here. But your institute approached them from the other side. That means something like you need cheap, low-cost, efficient enhancement to your processes. Nothing, rocket technology, but you need to start to think about improvement of your processes. And that's the main message. You try to learn them how to innovate. And that's something new, and we have to think it over in our National Center for Industry 4.0, in our Digital Innovation Hub, how to approach these small and medium companies.
I was going to, for me, this shoestring activity is not an alternative to what you're doing here. It's very complementary because this is taking companies into the future for their developments, and actually what we're just trying to do is to help some of the people that are way behind to catch up a little bit so they can ask for more advanced automation or more advanced systems in the future.
This is in some sense good advertisement for future, let's say, deployment of much more sophisticated technology. So this is the way how to approach them, how you try to involve them into the process of innovation. That's something what we need as well, and it was very, let's say, instructive for us that we need to attract them promising, let's say, processes of small changes, small innovations, which will enable them later to understand much more sophisticated enhancement or technologies or whatever. they have to start with something, the small and medium companies. Thank you for this. Yeah, please.
Yeah, no, I just to say, your colleague made the comment about getting small companies, even just to come to a workshop or a meeting is really hard.
Yes.
So it has to be something that they will have a quick win.
Yeah, it's necessary to use the associations of small, medium companies because they trust into their workshops and to their approach. They are a little bit afraid of the university environment, Cambridge University environment, so we need to bring them and to try to involve them into the process of finding innovative solutions. So I would like to thank Professor Duncan McFarlane for his presentation and for bringing new ideas how to enhance our cooperation with small and medium companies and what to do for them, and later on how to convince them that even, let's say, more sophisticated technologies can be introduced. Thank you very much, Duncan.
Une gestion de flexibility.